Calculus, position, velocity, speed, acceleration with trigonometric functions. Earlier in the year we covered this first semester, but we're going to look at this same concept, and there's a relationship between position, velocity, speed, and acceleration. Speed is just the absolute value of velocity. And here we have above the definition of a derivative, essentially. So the relationship between the position function, and the position function will have different types of notations. X of t tends to be the most common, but it can be any others. Sometimes it's verbally explained what it is. And then acceleration is going to be the second derivative of function. So I like just writing this down as like PVA and seeing the relationship between these. As you go down, you're deriving. As you go up, you're integrating. So just something to look at. And then acceleration, and then which is the second derivative. So s double prime of t, it's going to be your acceleration, or v prime of t. So you got to look at, again, this relationship between PVA. And then increasing speed and decreasing speed. Speed is increasing where acceleration velocity have the same signs, meaning both positive and both negative. And speed is decreasing when acceleration and velocity have different or opposite signs. Okay, we're going to go over two problems here. And again, we did this earlier in the year, but now this time we're using trigonometric functions. For t is greater than or equal to 0, the position of the particle moving along the x-axis is given by x of t equals sine t minus cosine t. What is the acceleration of the particle at the point where the velocity is first equal to 0? Well, the first thing we're going to do is take v of t is equal to x prime of t. And so we take the first derivative of this function here. What is the derivative of sine? Well, it's cosine. What is the first derivative of cosine t? Well, it's going to be negative sine. So we're going to have this negative cosine is going to become positive sine t. And now if we set this equal to 0, we will find velocity equals 0, where so 0 equals cosine t plus sine t, and so we can rewrite this as negative sine t equals cosine t. So what you're looking for in a unit circle, and again we're going between, for t is greater than or equal to 0. So for angles, we're rotating counterclockwise, and you're looking for a place where the signs of sine and cosine, the values are the same, but they're negative. And so we have positive, positive here in quadrant 1, here at pi over 4. But right up here, on this other side, at 3 pi over 4, we're going to have the signs opposite. So negative sine t is going to be equal to cosine t at 3 pi over 4. So, and now we're asked, what is the acceleration of the particle where velocity is first equal to 0? So I'm just going to bring this down here to give some room. So A of t is equal to v prime of t, which is equal to x double prime of t. And so that's going to be the second derivative. And so we take this function here. Your derivative of cosine t is going to be negative sine t. And then your derivative of sine t is going to be cosine t. So we want to find the acceleration of the particle at the point where velocity is first equal to 0. Well, that's going to be here at 3 pi over 4. So acceleration of 3 pi over 4 is equal to negative sine of 3 pi over 4 plus cosine of 3 pi over 4. Okay, sine 3 pi over 4 is going to be square root of 2 over 2. So that's going to be equal to square root of 2 over 2, but we have negative. Sine 3 pi over 4 is square root of 2 over 2, so we're going to have negative square root of 2 over 2 plus cosine 3 pi over 4. Well, cosine is negative square root of 2 over 2, so we have minus square root of 2 over 2. So this is going to be equal to minus minus. We're going to have minus 2 square root of 2 over 2. So our answer is going to be negative square root of 2. That's going to be our acceleration of the particle where the velocity is first equal to 0. Now B is the speed of the particle represented in part A increasing or decreasing at t equals pi over 6. Justify your answer. Well, what we look for is signs. Well, our velocity, if we take so our velocity is going to be cosine t plus sine t is going to be greater than 0 because we're in quadrant 1. So v of pi over 6 equals cosine pi over 6 plus sine of pi over 6, which is going to be square root of 3 over 2 plus 1/2, and that's going to be greater than 0. And an acceleration of pi over 6 at pi over 6 is going to be equal to, we have this function here, negative sine of pi over 6 plus cosine of pi over 6. So that's going to be equal to sine of pi over 6 is going to be 1/2, so we're going to get negative 1/2 plus square root of 3 over 2. And square root of 3 over 2 is a bigger number than 1/2. And so this is going to be greater than 0. And so since v of pi over 6 is greater than 0, and a of 6, a of pi over 6, is greater than 0, speed is increasing because v of pi over 6 and a of pi over 6 they're both positive. Both positive. So speed is increasing. That is our answer. So that's it. Let's go to the next problem. The position of a particle moving along horizontal lines given by the function s of t equals sine x minus square root of 3 cosine x. Again, sometimes we'll see this written as x of t. In fact, most of the time. Determine when the particle is at rest on the interval between 0 and 2 pi. So we're going to have v of t is equal to s prime of t, and that's going to be equal to the derivative of sine x is cosine x. The derivative of square root of 3 cosine x is going to be negative sine x, but it's going to switch the sign here because the derivative of cosine is going to be negative. So we have plus square root of 3 sine x. And so we can set this equal to 0. So 0 is equal to cosine x plus square root of 3 sine x. So if we put cosine x equals to negative square root of 3 sine x. Okay, where do we see that happening? Well, again, if we look at our unit circle, it often comes back to the unit circle, doesn't it? What we have here, we're looking for pi over 6, at 5 pi over 6, and we have 7 pi over 6, and we have over here 11 pi over 6. What we have is at 5 pi over 6, for instance, our coordinates are going to be negative square root of 3 over 2, comma 1/2. Well, what's going to happen is if we take the sign and multiply the sign, which is 1/2, by negative square root of 3. So we have negative square root of 3 times 1/2 is going to be equal to negative square root of 3 over 2. So that's going to occur at 5 pi over 6 and at 11 pi over 6. And so we'll say since s prime of t equals 0, where x equals 5 pi over 6, x equals 11 pi over 6, particle is at rest where x equals 5 pi over 6 and x equals 11 pi over 6. So really, that's it over this interval. And that's what we have today. I hope this has been helpful to you. Good luck, and thanks for viewing.